Hi everyone, this is ABAQUS, and here in this video we are going to learn how we can simulate a fiber reinforced composite using ABAQUS CAE. Today's problem relates to elastic properties extraction of a composite. As you can see here, we have a unidirectional composite, and as a unit cell we can select one force of this model, includes the fiberglass and epoxy resin. As you can see here, we have the elastic modulus and the Poisson ratio for both resin as a matrix and glass fiber as the fiber here. Also, the radius of the fiber is 0.08 millimeter, and the dimension here is 0.1 millimeter, which obtains from the volume fraction of the fiber. As you know, these two amounts are exchangeable, and we can obtain each one with the other one. So the problem is how much is the elastic properties of this composite, reinforced composite, using the elastic properties of glass fiber and resin themselves. So here, as an instance, we are going to obtain E11 and nu 12, which is equal to nu 13, using this axis. So let's dive in. Okay, we start from the part module. Okay, we start from the part module, but first it's better to change the graphic option to, for example, to white, and okay, I think it's better now. So we start from the create part and made a 3D deformable solid and extrusion. And here you have to choose, maybe it's better to choose one, then click on continue, and here we are going to draw a square like this, and apply the dimension, which is 0.1 for this length, and here also 0.1 for this length, and approve it, and apply the 0.1 depth as well. Click on OK. Now we have to make the fiber here in this face, so it's better to choose a partition face and select this area and this line and this line as well. Now we have to create an arc, which the center is here, and it goes, for example, until here and comes to here. Apply the dimension, which is 0.08 millimeter, and approve it by mid click, and everything is alright. Now we can now everything is alright, and we can make a partition using this face, and then select partition cell, extrude, now select this arc and then choose this line and use the partition. As you can see here, we made our fiber. Okay, now we can go to the property, and here we have two types of material. First one is the glass fiber. The elastic amount, the Young modulus of this glass fiber is 75 gigapascal, which is 75E3, and the Poisson ratio is 0.08, and this one is okay. And another material, which is the resin or matrix. Also for the matrix, we have the Young modulus equals to 2 gigapascal, 2000, and Poisson ratio equals to 0.35. Click on OK. Then we have to make two sections, which first one is the fiber. Is a solid homogeneous material. Choose the fiber here and click on OK. And the next one is the matrix, which is also solid and homogeneous material. Click on continue and choose here the matrix. Okay, now we have to assign these sections. First, here, select the matrix section, click on done, select the matrix, okay, then select the fiber, choose the fiber, okay. Now you can see that we assign all the material to our model. You can also check the material using the icon here. Materials, okay. Now we can go to the assembly and insert our model to the assembly part, to the assembly module, and click on OK. Go to the step and make an step, which is the static general analysis step. Click on continue. This is not a nonlinear analysis, then you have to select off for the nonlinear geometric analysis and go to the implementation and choose 0.1, for example, for the initial, and the maximum amount is 1. Okay, click on OK here. Go to the load part, and here we have to apply our load. So click on boundary condition, and the first important boundary condition is the symmetric the symmetric faces. For that we have to select symmetric here and then choose, for example, this face. Okay, here we have the Z, as you can see, the symmetry in the Z direction. Choose this one and click OK. And also for the bottom faces here, we have to apply the Y, as you can see, Y. Y direction symmetry. Okay, click on Y direction. Okay, now we have to apply an encaster boundary condition to this node. Then click on continue, choose this node, click done and choose encaster. Then we have to bond these faces in the X direction. Okay, here we have to take U1 on. Okay, now we have to apply a displacement on this face. Continue and select these areas, click on done, and here we have to apply, for example, 0.1 and click on OK. Now everything is fine and we can go to the next module, which is the mesh module. Select the part here and use the seed as, for example, 0.005. Looks good. And here you can select the type of the mesh, which is the hexagonal structural element. Click OK. Then you can mesh it, as you can see, like this. Okay, you can go now to the job, and here we can create a job. Continue, click on OK, and submit this model to the ABAQUS CAE. It goes to solve it. You can check it using this icon monitor. Okay, now the solution is done, and we can go to the result part. Analyzing the result is very important for this problem. You can see this is the von Mises stress on the fiber and matrix structure. You can change the results to the strains and U and displacement. For example, displacement in the one axis, which is the x-axis, okay, U1. Now we have to obtain the E11. It means that we apply the load or stress in the one axis, and then we want to apply the stress strain curve on this axis. So we have to get data from this icon. Click on ODB field output and click on continue. Here you have to select unique nodal, and here select reaction forces on the one axis, and here displacement on also one axis. Here go to the element node tab, and here click selection, and now we have to select some nodes to operate them. Okay, we have the x-axis here, then I choose this one, and also this one. Okay, I can make a box here to select all the nodes attached on this face. Click on save here. Okay, now we have 473 nodes selected. Now we have to go to the operate XY data. Click on OK. Here we have the reaction forces on this face. So we have to add or make a summation for all of these reaction forces. Then I use the summation here and select all the reaction forces that I selected before. Until the last one here. Okay, add to expression and say this as for example force. Okay, you can see it mates. Okay, now you can delete all this expression. Also you can obtain the stress from this force, just dividing this force to the area, which is 0.1, which is 0.01, and save this one as stress. And also we can obtain the strain using one of these displacements, no matter which one, because all of these parameters are same. You can select this one and divide it to the initial amount of length, which is 0.1 here. And you also can save this as a strain. Now we have stress and strain in these descriptions. Let's find it. Let's find them here. Here. Okay. Now we can draw our stress strain curve using the combine command. First select strain and then select stress, and you also can save this as stress strain. Click OK. If you plot this curve, you will see the stress and strain curve. This is not a true force displacement, but stress and strain. And as you know that the slope of this curve gives the Young modulus E11. Also we can calculate the amount of E here using these commands. For example, if I divide stress divided to strain, and we can save it as Young modulus. Click on OK. And now we can plot this Young modulus, which is here. As you can see, the Young modulus for this composite equals to almost more 36. You can check it here. Young modulus, which is 38 gigapascal. 38 gigapascal, as you can see here. So this is the Young modulus that we obtained for this FRP. Let's check it back. We had 35 gigapascal for the glass fiber and 2 gigapascal for the epoxy resin, but E11 is almost 38 gigapascal. You also can find nu 1,2, which is equal to nu 1,3 using this expression. Strain on the 2-axis divided to strain on the one axis like this. You can follow the procedure that I have made for E11, and you can calculate amount of new 1, 2. Hope this video will be productive for you, and hope you enjoy this video. Please subscribe my channel if you like it. Thank you very much. See you later.